Hello, everybody. This is my third iteration on the locks tool that I've been creating um, for CS842. And I wanted to show you that I have gotten it to now work on Linux, both KDE and GNOME. So, uh, again, this is Rust code, so I've already pre-compiled it, but if I wanted, I could run it again, and you would just see that it's already been compiled. And it was quite interesting to try and get it to work on Linux because Linux uses the dbus interface. And so I had to adjust for some things in order to get that to work because many of the tools talk to each other over the dbus interface. And there's this API called the secret service that is supposed to work with the GNOME keyring and the K wallet. So I believe I've already got it compiled on this one. Oh, I guess not. So anyway, I'm going to show you that it works just like it did on my Mac and Windows VMs. I have now gotten it to work on Linux. And to show you ahead of time, I've got the passwords and I've got the keyring open or the K wallet on the other OS, and this code can be found in my repo. I've renamed it a little bit so it's a little easier to find instead of just module 2. But there's two parts to this library. There's the actual library itself that could be included with any other future Rust project. And right now it just targets Mac, Linux, and Windows and goes from there. And then based on the current operating system that you're running, it knows to pick up the correct keyring associated with wherever it's being compiled. And if there isn't a default one, then it just emits a compile error. So that's pretty nice. But from a library perspective, the only thing you should need to call is just get OS keyring, and then you're done. And it goes from there. So then every keyring implements the keyring interface. So you can get a secret, peek a secret, set secret, and delete a secret. And so on Linux, there's this nice interface called the secret service. And you can talk to it over just plain text, or you can encrypt it and do a Diffie-Hellman exchange. So that's what I've done because we're interested in keeping this stuff a secret. And just like every other keyring, you have to check if it's locked or not. And if it is, you try to unlock it, which should prompt the user through the operating system that it's unlocked. And then you can go from there. The difference between get a secret and peek secret is get is when you do get and set, that's managed by locks, whereas peek is not. Peek is intended for my next iteration to basically say I want to just see what's in the key ring that's just there, but you have to know the name of it. So I have not implemented how to list all of the secrets in a keyring yet. So once I do that, you could use that peek and list to pull out secrets. But anyway, for this one, I just implemented get, set, and delete. And Linux requires a little bit more information than Mac or Windows. Mac or Windows usually just require the username and the service name and then the actual key ID. Linux required even to know what application it was, so for now I just hard-coded it to locks. Maybe I could expand that later. So if those are done, and it looks like they are, so I have the keyring up on, this is Ubuntu, but the same works for any Red Hat. So Debian or Red Hat, I've tested this, it does work. Let's make sure this runs. Okay, it does. So it's asking me, just like always, to put something in there. So I love to put my AWS credentials in there, and obviously I haven't put any in there yet. So as you can see, I don't have anything in there yet. So this is asking me to put something in, and it says it successfully put in there. Oh yay, great, there it is. So I can open it up, and you can see those other details that they tagged in there. It says only Mike should access this. This was the application that did it, and so on. So, and then I can delete it, I should be able to get it, which I can, and then I should be able to delete it, and then it's not there anymore. Now this is Kubuntu, which is KDE based. It should be able to do the exact same thing as the Ubuntu edition. So again, I go in there and I say, give me my AWS key, and it goes, oh, okay, let's unlock the key ring. So I will do that now. And it says, oh yeah, you got it in there. I already had put it in there. But let's say I wanted to overwrite it with something else. So I just hit a bunch of random keys, and there it goes, it updated it. Or I can delete the key, and then if I try to call it twice, it'll say, oh, it's not there. It's not there. So I've touted that Lox has not required any external dependencies on Linux. It does require an external dependency called dbus. So as long as you have dbus installed, then it works. And I've tried it on some headless systems. So if I had the time, I would run through this and you could watch it compile, and it would work. And then we could get it to... this is a headless system, and you would see it doesn't work because I don't have... Most dbus systems, like on servers, are not installed due to some security properties. So if I were to try and run Lox on this system, which I'm trying to compile it right now, it won't work. It'll say the dbus interface doesn't exist. And this dbus, the Secret Services API, is managed by org.freedesktop. So if you have that installed, you might be able to get it to work. From what I found, there's a lot of dependencies on UI components, and you probably don't want those installed on a headless system. So maybe in a future edition, I will try to get it to work on a headless system, but I may not be able to use dbus or anything like Kwallet or GNOME Keyring, which is a bummer, because then that means I'm going to have to implement something else entirely, and then it can't read the OS. It won't be able to read the OS credentials, and they'll have to use some other ones by default. So anyway, that's it for now. Hope you guys enjoy it, and I look forward to the feedback.